So welcome back. We're going to continue talking about exponents. We're going to pick up on a few more rules of exponents that we can take advantage of. As we said earlier, if you have a repeated addition was represented by multiplication. So if I had 9 plus 9 plus 9 plus 9 plus 9, that's 5 times 9. And of course 5 times 9 would just be 45. If I have m plus m plus m plus m plus m, that means we have 5 m's multiplied together, or we might have as 5 times m. Again, we can't do anything with that until we know what m actually represents. So at this point, m is just an unknown until we know more about what's going on there. So that just becomes what we call an expression. Meanwhile, over here, if we have 9 times 9 times 9 times 9 times 9, that's when we're going to use that exponent or power. So that's 9 to the 5th power. And again, if I use my calculator, 9 to the 5th power, that's going to be like 59,049. So 59,049 is a much bigger number. So keep that in mind. There's a big difference between adding 9s and multiplying 9s. Also, if we have m times m times m times m times m, a simple way to write that is using an exponent and write that as m to the 5th power. So that's the advantage of exponents, is it's kind of a shortcut to repeated multiplication. So it's a nice little symbol to come into play. Let's continue on with some more examples. So let's look at m to the 3rd over m to the 4th. So if I have m to the 3rd over m to the 4th, we know that m to the 3rd means m times m times m. M to the 4th kind of means m times m times m times m. What we're picking up on is, since this is division, we're seeing those factors are the same, we can divide those guys out. So I can divide out 3 of those m's, and I'm left with an m in the denominator. Since there's nothing in the numerator, we use a 1 as a placeholder, so it's just going to be 1 over m. Because remember, when you're dividing, m divided by m is turning to 1s. So this really means 1 times 1 times 1, which is 1. Okay? Now remember, we also have a rule that says if we're using division, I can subtract those exponents. So I could do this as m to the 3 minus 4. In other words, that's the same thing as m and a 3 and a negative 4. So what we're picking up on is a 3 and a negative 4, that actually is going to give me a negative 1. So m to the negative 1. So what we're coming up with is what we call a negative exponent. So I have a negative exponent. Now, what we're picking up on then, though, is m to negative 1 is the same thing as 1 over m. So we're picking up on that negative exponent actually means to flip or take the reciprocal of. So if I have something raised to the negative 1st power, what that really tells me to do is to flip it, move it to the denominator. So we actually end up making a fraction out of that. So negative exponents are going to be a way to actually write fractions, believe it or not. So for us, probably not going to do a whole lot of that, but if you're going into a science pathway, like scientific notation uses a lot of negative exponents, we have to understand what those things mean. But for us, probably not going to use this again except in our algebra classes. But all it really means is to make a fraction, or in other words, to flip it. Okay? So if I look at this example here, m to the 3rd, n to the 3rd divided by n to the 7th, there's, again, 2 approaches to this problem. One way to approach this problem is say, hey, I've got 3 n's, oops, let's try that again. Make those n's. I have 3 n's in the numerator, and I have 7 n's in the denominator. So I have 1, 2, 3, 4, 5, 6, 7 n's in the denominator. What pick up on, since this is a division problem, I'm allowed to divide out like factors. And what we end up with is 1 over n to the 4th power. What I can also do with this problem is, if I have a division problem, I'm allowed to subtract exponents, m minus n. So if I look at this problem, I have n to the 3 minus 7. So it's going to be n to the negative 4. So since I have a negative exponent, that negative exponent is actually like an operation. It's actually telling me to flip the guy, flip the expression. So that n goes to the denominator, and I have 1 over n to the 4th power. So that's what n of the negative 4 actually means, is to make it a fraction, write it as 1 over n to the 4th. Okay? Let's look at another example here we have. K to the 4th divided by k to the 4th. Well, we should pick up on that. Anytime you divide something by itself, it should turn into what number? Or what we're picking up on is these k's are just dividing out. In other words, we end up with just a 1. So anything divided by itself is just going to turn into a 1. Now, if I'm using the rule of exponent, if I have a division problem, what it says I'm allowed to do is subtract those exponents. So I can write this as k to the 4 minus 4. And that would be k to the 0 power. So what we're picking up on is an exponent can actually be 0. And what does that 0 really mean? So what this is saying is anything to the 0 power is just going to turn into the number 1. So that's another property we have, is if the base is raised to the 0 power, my answer is going to be 1. Anything raised to the 0 power is 1. So that's one of those easy questions if you know what that exponent means. And all it means to do is turn it into a 1. So if we look at this problem right here, I have 2 times j squared times j to the negative second. Notice how this is multiplication. Multiplication, if the bases are the same, I can actually add those exponents. So notice how I have a 2, and then you have a j to the second times j to the next second. So what I could say is, well, that's the same thing as 2 times j, and you can write that as 2 plus a negative 2. Because remember, if you're multiplying, the rule says you can add exponents. Well, what is a 2 and a negative 2? Well, it's going to turn into a 0. So what you have is 2j to the 0 power. And what we pick up on, though, is j to the 0 is the same thing as the number 1. So I can change this to 2 times 1. So what that does is that simplifies down to a 2. So this actually is the same thing as 2. Now what I could do, though, is another method on this problem is the 2 and a j would stay in the numerator, but that j to the negative second, since it's got a negative exponent, that negative exponent means to move it down to the denominator. So another way I can write this problem is 2j squared over j squared. So since these aren't raised to negative exponents, these two pieces stay in the numerator. But notice how this j is raised to the negative second. That j to the next second can go to the bottom. And notice once it moves to the bottom, it's no longer negative because I performed the operation. So once I move it, it's no longer a negative exponent. And notice that these j squareds would divide out, and we end up with our answer of 2. So that's another way to look at this problem is I can get rid of negative exponents by actually moving to their side with the fraction bar. So those are a few examples to kind of get our teeth kind of sinking into some concepts of exponents. We're going to try to raise this to the next level of simplifying some expressions a little bit more difficult than these. So stay tuned for those.